Dr. Barrie Tan, welcome to the Keto Camp podcast.
Thank you. I'm looking forward to this.
I have been looking forward to this. I was telling you that my friend and colleague Cynthia Thurlow interviewed you on her Everyday Wellness podcast, and she told me you blew her mind, and I had to bring you on. And I started researching you ever since she told me that, and my mind has been blown. And I'm excited to have you here. You were just telling me offline all of these new things that are coming out. You were sharing with me, some of the structures that you want to cover, and we have a lot to cover. So
Yes.
let's dive right in. I'm always fascinated by this. Why does somebody dedicate their life to a certain topic, like certain research? And for you, it's vitamin E and really debunking some of the myths surrounding vitamin E. But how did that even start? What was the story, the backstory about vitamin E for you?
Yeah. It started. I it's partly accident, partly as I went into it, I got more and more excited. It started during my career as an assistant professor at the University of Massachusetts, which is not far from me now. I'm no longer there. I left there about 30 years ago, and I was studying vegetable oil at the time. And then, not surprisingly, in vegetable oil, you found vitamin E because vitamin E is found in, and vitamin E is used in vegetable to protect the oil from going rancid. So sometimes we got it into our head that we a plant makes all this lovely thing for us. Plant never make anything for human being. We should be thankful that we got it from the plant. So, but the fact that plant makes more vitamin E than their oil tells us a lot, because the
Mm.
oil will go bad quickly, and therefore they protect the oil from going bad, what we call rancid, like that. So I know you're going to ask about our body fat, this and that. That's when I can tell you why I'm specifically interested in this kind of antioxidant and cut out all the other noise, because everybody and their grandmother's dog is claiming the antioxidant can do this, and so it's very confusing for the listener. So I'm hoping to debunk some of those and clarify some positions.
Oh yeah, I can't wait. So you were studying vegetable oils, and we know that vegetable oils, they're polyunsaturated fats. They have a lot of these double bonds, and they're very unstable. So you're saying the vitamin E that's naturally in the plants helps to protect that oil from becoming rancid. But how effective was it to protecting vegetable oil? Because from my understanding, vegetable oil is still pretty toxic and rancid and
Yeah.
unstable, even with the vitamin E.
That is a question. That is a good question, because the vegetable oil is inside the cell like corn. When you eat corn, you don't feel the oil, but when you process the corn to cornmeal starches, this and another thing, and then out come corn oil. So when it comes to corn oil, it's no longer inside the cell. It's no longer inside. Well, in the plant you call it the cytoplasm, in the plant cell, like that. Now that has significant meaning when it comes to human cell. I know you're going to ask me later. So when you process the vegetable oil, it's not really in cell. It's just like an ocean of water, ocean of oil, like that. So and yes, sometimes the processing, if it's gone not properly protected, it goes bad. And now, if we were to talk about pulver from vegetable oil, we have lots of things to talk not positive about. But let's think about the positive thing and how to protect it. Everybody loves omega-3. DHA and EPA, they are even more unsaturated than pulver or vegetable oil.
Yes,
So
yes.
I've been telling people like mad, when you take omega-3, which is a good thing, can you please take vitamin E to go with it? If it is not, this wonderful omega-3 goes into your blood, lands into your cell wall, and then there's nothing there to protect the omega-3. That's not a good thing.
That's really important. I talk a lot about the dangers of fish oil all the time. So you're saying if you're going to take fish oil, take it with vitamin E, the right vitamin E, which you'll
Mhm.
talk about, which is more protective because they even have more of these double bonds. They're very unstable. Now, with the vegetable oils, maybe you could just share, because even let's say somebody is processing vegetable oils the right way, where it's not as unstable, it's not as rancid as you said. What happens when it enters the body, though? The vegetable oil, even if it's processed somewhat better than other vegetable oils, what happens when it enters your cells?
When they enter our cell, first it get into the blood, and then they travel with a scientist call it lipoprotein particle. Pretty much these are particles that have one or two proteins in it, mostly an ocean of phospholipid with the fat. So it's kind of like a carrier. And then they carry this to the gazillion trillions of cells in the body, and then it get landed onto the cell, and then it become part of the cell wall of the cell. That is the final resident place of fatty acid. People don't usually think about that. I know when we eat too much fat, we have our love handle, this, that, and other places, but that is not where most of the fat are landed in the place that you cannot touch. It is on the cell wall of the 38 trillion cells. That is about 5,000 times the population of the earth, and then the entire cell wall. And that is very important. While I'm at it, I might as well say it. Think of the cell wall that contain the nucleus, the mitochondria, all these wonderful things in a cell that does all the good things. Think of it like you live in a gated community. You want the good guys to come in and then the waste to go out. In the cell, it does the same thing. Your nutrients to go in, sugar, fat, good things to go in, and things you don't want after the refuse is being made, it go out. That would only work if the cell wall is a properly gated community and not compromised. Now, about 80% of the cell wall is actually fat. 80% of the cell wall is fat. So just think about that. 80% of cell wall in every cell in your body and mind. I consider that to be the rudimentary, primitive way of understanding aging. I know people have aging in many other things. I consider that as aging, and I call it primitive because it was always there from day one before we got all this horrible illness like that. Good things go in, bad things come out. Now that I convince you on that, let me go a step further. In the 1980s, there was an Austrian professor. His name is Esterbauer, Estabeur, some German-sounding name. You can type his name. You can Google his study. For at the time, he was just obsessed by the idea. What exactly are the antioxidants on the cell wall that protect the cell? And when he deciphered all of that, I was surprised and pleasantly surprised that greater than 90% of all the antioxidant on the cell wall, they are vitamin E molecules, meaning tocopherols and tocotrienol. And less than 10% of them are, you can count it on your hand, CoQ10, which our body makes, lycopene, and beta carotene. Then you say, wait a minute. I've heard a lot of podcasts and everybody talk about resveratrol, quercetin, and go on and on and on and on like that. All this, yeah, they're antioxidant, but they are not landing in the place where I consider it important to have the gated community. So right now, if I can convince your audience, this is it. And it has actually nothing directly to do with what my tocotrienol is. Eventually it does like that, would be that if you drive past on a hot summer day, you drive past a roadkill, that smell. If you have a stick of butter on a hot summer day and then you go back and smell it 2 hours later, that smell, that is oxidation of fat. We have 4 major food groups. Usually people think of 3. I add 4. Fat, protein, carbohydrate, and surprisingly, nucleic acid. We need nucleic acid to make DNA. We usually don't think about them. If you eat meat, you have plenty of those, right? Of these 4, any of them seriously oxidized is no good. I give you that, But for example, by the time my nucleic acid is oxidized, I am royally dead meat because the oxygen have gone so into the nucleus and sucked my nucleus dry, and then I'm gonzo. So but the first thing to get oxidized is actually the fat. Because, that's why I told you about the butter thing. It's the lowest lying food to get oxidized. So therefore, when people ask me what antioxidant should you take, you cut all the noise out about the 10,000 antioxidant. Then you say, what are the antioxidants that will protect the fat that line the cell wall of all the cells in my body? Once they answer that, you got the answer. You will have a reasonable chance of living a well active life, well meaning, age happily, and you keep yourselves happy because you have a good gated community. That if they function well, then you eventually as a whole person will function well. I try to tell these people very simplistically and not go to other gibberish, and then people lose into translation, so it is like this. And also when a cell is ready to die, we call apoptosis, not apoptosis caused by cancer, normal apoptosis. And then in 2019, some Japanese scientists got the Nobel Prize for autophagy, which means that the time all of us have a finite time. I cannot live forever. The time will come. I can't breathe. My brain is not working. I'm gone like that. But I want to live meaningful life until then. The cell does it too. So it will go to apoptosis. For example, your white blood cell, your platelet, have 2 weeks lifetime, and then they go away. If your white blood cell hang around for 3-4 months, something is wrong. Keep in mind, see? So living forever is not living forever. Is the idea we think, hey, cancer live forever. You see, there's something funny about that thinking, but you live as is normally supposed to be. Red blood cell. I only mention this because we see red blood cell and this thing. Red blood cell usually live for 3 months. That's it. And then it wind down, it got a clock switch off, and then it get apoptosis, and then new one comes about. So in the human body it's the same. But if the gated community is not kept well by antioxidant, then you begin to hear things like, oh, the telomere, which is the DNA, inside the DNA got shortened, and then something is a short-circuited, life goes short. All of those are true, but I gave you the simplest understanding. You protect the cell wall, then everything will come back into kilter. So sorry, I've taken longer. I know you didn't even ask me on this, but I hope that your audience will get this. This is simple and it's not complicated at all.
That is really good. So I have some clarifying questions on what you shared. You said 80% of the cell wall is made up of fat. Do you know the percentages of what is saturated fat, cholesterol, just the percentages of which type of fats are in that cell wall?
The fat in our fat reflects two things. It probably prominently reflects the fatty acid we take, which of course, if it's a huge amount of omega-6s that you and I know is not a good thing with our industrialized career like that. Our body also make omega-3. But with the onslaught of the amount of omega-6s we make, it's hard for our body to overcome that. And hence, many scientists advise us to take more omega-3 or fish oil or eat fish to help to supplement that. And then we consider cholesterol also as a fat because it's waxy, but it's not a fat in a fatty acid as such. The cholesterol is made by our body and is in the cell to think of a cell like this. So the cell is moving like that, undulating like that. And so the cholesterol is there to give the pliability of the cell like that. So it's not too rigid and not too stiff. If you take a lot of saturated fat, then it'll become more immobile. If you take more double bond polyunsaturated, then it's more flexible. Then the downside of the flexibility is it's got a lot of unsaturated bond and the oxygen is going to attack. Basically, the oxygen does not have a life. We need oxygen to live. 1 in every 10,000 oxygen, they become radicalized, meaning that it had 2 very active electron on the oxygen. It doesn't know what to do. So the potential energy is high. It's looking for something to take away the energy. Then it settles down again. And the best way for it to do is to go after double bond. That's just chemistry. Nothing to do with life. So if you just stick in active oxygen, it'll do that. What would be a, see, I'm actually trying to do this. I've studied science for so long. I wanted to communicate easy understanding to people. What would be a very radically active oxygen? Ozone. Next time you crank your engine, you because you had to fix something, you put the hood on, you smell your engine, something very steely smell. That steely smell is O3. See? It's got 3 oxygen molecules stuck in one molecule. That is super active, because oxygen is supposed to be O2. Now, one oxygen is not good. One oxygen is connected to carbon monoxide. That's a bad word. You don't want to have carbon monoxide in a closed garage with your engine on. That's not good. Like that. So too little oxygen, bad news. O2 is what we live by. O3 is hyperactive. So there you have it. So oxygen have all this chameleon position. So we want O2. But it is possible that 1 in 10,000 oxygen will go haywire, and when it does, it's going to go after double bond of unsaturated fat, and it doesn't screen one from the other. If it happened to be linoleic acid with C18, it goes after that. If it's fish oil omega-3, it would go after that, like that. But then at the same time, we cannot eat a lot of palmitic acid and stearic acid, which is saturated. If you do, then the cell wall is unable to be pliable, and then so the gated community is almost like the drawbridge doesn't come down. Just think of a castle, like it just doesn't come down. Well, if it does, because it's creaky, it just doesn't. If it doesn't come down, well then things cannot go in and things cannot go out. That's not good also. So I would say, because we are kind of out of kilter by taking too much 18 carbon fatty acid, more of C22 and C25 is good, and they seem to be found in marine organism, whether it's crustacean or fish. Fish is just an easy, inexpensive way to consume. So,
this is really good. Okay, so the composition of your cell membrane will be dependent on what type of fats you're eating. That makes a lot of sense, obviously. And the goal is not necessarily to just eat a whole bunch of omega-3 and not eat omega-6. The goal is to have a nice balance of both, so the cell has enough fluidity to allow good things in and bad things out.
That's correct.
So, I know this is a tough question to answer because I've never seen the answer in terms of an easy way to answer this, but is there a way that the average person could test the fluidity of their cells to see how fluid or rigid it is? Some sort of test?
To the best of my knowledge, no. People have tested fluidity ex vivo. Ex vivo meaning that you harvest your cell and then you look at it outside. Now, when you do that, right, it's kind of like depending on a marker. So how reliable that marker is, nobody seems to know. So I don't know of anybody able to do something that directly measure that. So the closest I can think of that to be done, Ben, would be that if you go and see a doctor, they have a machine that can study the pliability and the flexibility of your artery. That will be the closest I can think of doing that like that. A cardiologist will put all kinds of electrode on your body and see the ejection fraction of your heart, because your heart is continuously moving, but that is organistic. But as to actually measuring the cell, no, not that I know of, unless you take the cell outside.
Yeah, okay, that's good. And then what role does cardiolipin play here? You mentioned apoptosis, which is this programmed cell death. From my understanding, cardiolipin plays a role here, which is this lipid raft that there's a signal sent via cardiolipin, and cardiolipin will determine, you tell me if I'm right or wrong, cardiolipin will determine if that cell lives or not. Do you know much about cardiolipin and the role it plays in the cell?
The ketogenic diet is all the craze these days. Rightfully so. Using keto could be a powerful way to achieve extraordinary health results. And if you're interested in keto, but just so confused by all the information out there, you're gonna wanna watch this video. If we're just meeting, my name is Ben Azadi. I'm the best-selling author of 4 books, including my recent book, the best-selling Keto Flex book. And I'm excited to share with you about a new 7-day Keto Kickstart Challenge where I'm gonna reveal my 4-pillar framework to achieving long-term results with keto and fasting. This 7-day challenge is 100% completely free. Me and the Keto Camp team are gonna teach you the blueprint that we've used to apply to thousands of our clients for amazing results. There's a lot of information out there, and it's enough to leave you confused, conflicted, and paralyzed with your thought process. What we're gonna do is take all that clutter and cut through the noise and give you a simple step-by-step 4-pillar framework so you could achieve extraordinary results with your health. I really want this to be your healthiest and best year ever, and this challenge is going to help you accomplish that. So what I want you to do is click the link around this video here, learn more about this 7-day Keto Kickstart Challenge, get signed up, and we'll see you in the 7-day Keto Kickstart Challenge.
No, I have heard other people talked about it. I don't know to measure that, other than to say this. To measure the life of a cell, there are several measurements, and I'm not at odds. I read about them. Sometimes people like to use a marker, because if you have a marker, you can measure the marker. You can say this is good or not. I know it's simple, and I know it can be powerful like that. I have seen people done that. I also seen people measure the life of the cell. So if the cell normally live, let's say the cell lived to 1 month, and then they do something to the cell, then the cell live about 25 days, and then they do something else to the cell, they live to 35 days, then they have a normal distribution. So now that is a cellular study. Notice that? It's not a marker cellular study. And then other people decided that, they want more organistic study. So the common organistic study that people use would be zebrafish, because they map out the zebrafish, or C. elegans, which is the worm, because it's a whole organism. And then if the worm is a classic one, they live typically to 30-35 days. So they put tocotrienol in this worm, for example, and then they measure the telomere, the DNA, this and that. But at the end of the day, they wanted to see how long the worm live, and the worm typically live about 25 to 30% longer. That's it.
Wow.
So if you ask me, if I can see the worm living 25 to 30 days longer, I rather accept that than some cell study like that. I mean, in human being, if I were to be in 70 years, if I live 30% longer to 100 years, well, after I've done that experiment, I can't be sticking around to do another experiment. So people don't have those studies. The closest that
Right.
people have done that kind of longevity study is University of Wisconsin. So they study primate monkeys, and then they have done this. And I don't know right now, because a lot of this study, right, you have to stick around for like 30 to 40 years to look at the life. So
Yeah.
so that's difficult to do. So therefore, people have zebrafish and C. elegans. So I know for a fact that the tocotrienol help to reduce the stress on the worm, and the worm typically live about 25 to 30% longer. So for that utility, if I'm 70 years and I can live to 100, man, I'm as grateful as I can be.
That sounds like a success in my book as well. Okay. All right. So you mentioned antioxidants, right? A lot of people, they're popping antioxidants. They think more is better, more is better. You just shared that out of the thousands and thousands of antioxidants out there, 90% or more for the cell wall specifically, it's going to be composed of vitamin E. And does that mean you're against taking CoQ10, you're against taking lycopene, or you're not against it, but it shouldn't be your main focus, is what you're saying?
Yeah, the CoQ10 thing, I believe, is an endogenous. The body make very few endogenous antioxidants. Oh, if the audience want to know, let me tell you the 2 or 3. You see, it's no 10,000. The very few antioxidant the body makes are these. CoQ10. CoQ10 is a true antioxidant, and the body makes it. So for whatever that is, that's something to take note of. Another one is glutathione. People call this a master antioxidant. I don't know if a master is more a claim that an antioxidant, yes. And it's a 3 amino acid together like that. So that's that one. And then, and not selenium, but our body doesn't make selenium like that. The other one may surprise a lot of people. In women, before menopause, before menopause, they make estrogen. And I look at the molecule of estrogen. Estrogen is an antioxidant, which is why I am under the curiosity that after menopause, women have more oxidative challenge. I'm thinking through that a little bit more. Next time when you're not with me, you go online, you Google estrogen, and estrogen precipitously drop right after menopause. And the structure of estrogen is antioxidant. Those are two. But men doesn't produce estrogen, not to the extent that women does. So therefore, I cannot. So therefore, most antioxidant we get from external sources thanks to the plant. Now, while I'm at it, other people may say, I find it hard to believe what Dr. Tan said. There are tens of thousands of antioxidant plant make, and the most common one the plant makes are polyphenol. We read like a lot about this, EGCG, resveratrol, quercetin. Human never make this. The plant makes it. The plant makes this because in the plant does not have huge amount of fat, because most of the plant don't look like avocado. They don't look like the fat in coconut. They don't look like that. They just look like, think of spinach, think of cauliflower, think of things like that. Think of EGCG in tea leaf. What fat? There's nothing there. So they are supposed to protect the cell. So in the cellular thing, which is low in fat, many of these polyphenol kicks into action. However, when it comes to human being, we are overweight and we are obese. We have other problems that are definitely fat related. So if that is the case, we need less of polyphenolic protection, like the polyphenols would protect the leaf. We will need the kind of antioxidant protection that would protect the vegetable oil, the avocado oil, or inside the seed where the fat is. Think about that. This is how the plant makes it. So if that is the case, then the antioxidant we need, they mostly look like vitamin E molecule. Now, I have a structure here. That is a structure of tocotrienol, like that. If I purposely go out of screen, see that? The black color is carbon, the white color is hydrogen. That is totally hydrocarbon. That means it sticks deep inside the fatty acid of the phospholipid. If I come closer to you, you see that there are 3 points where there's like an O-ring. That's a 3 double bond, and hence triene. Now, if I go the other side, that's the antioxidant. That's a phenolic ring, and that's the antioxidant where my finger is pointing. So if you have this thing here, this one here is seated deep inside the phospholipid, and this one here is outside the cell wall. And if it's an oxygen radical come in, it zaps it. If the oxygen radical get into the double bond, it opens up, take the oxygen, and come out like that. The molecule that is an antioxidant in the fat has to look like this. I'll give you one example. Now, you're gonna feel some pain when I tell you this, like that. But you should know this though, because otherwise you go buy expensive stuff out there. It doesn't work for you, like astaxanthin. Everybody know astaxanthin. Like that is good for you. Oh, like that. Astaxanthin has this side here, OH group here, another OH group here. So it's a double-headed thing. So that is a good antioxidant. However, astaxanthin on the other end here has exactly the same thing here. So therefore, if you have a phospholipid, water-soluble and lipid-soluble, how are you going to expect? Think of this as a two-headed snake, a snake in the head and a snake in the tail. So if you have astaxanthin, this astaxanthin would work like this. It'll come out sticking out like that. This is as awkward as it's ever going to be, because all the phospholipids are like this. How about for the moment you don't believe me? You go on a textbook and just Google and ask what a cell wall look like. Then you can see How is this monkey going to get into the phospholipid? It won't go in there. So therefore, do not take things that does not fit. It really doesn't fit. It has to be like this. So I usually tell people that an antioxidant that work, they look like a sperm or a tadpole, where the head is like this sticking out and this thing sticks in like that. Now, in the back of me, I'm going to go away now. In the back of me, here, I want the audience to see this. Okay, that is the CoQ10 molecule. I'll take this away. See that?
Yep.
On the CoQ10 molecule, on the other end, that's the antioxidant. It sticks out, and this big, long tail sticks into the phospholipid. So when our body make CoQ10, it stay there. It is its permanent residence. It usually never moves from there.
Huh.
And also, if you take supplemental CoQ10, I'm tell you, everybody and their grandmother again, you will say the CoQ10 is 200 times more bioavailable, 300 times more bioavailable, making you to buy their product essentially. You know why they do that? They do that because they never tell you this. And probably they don't know. CoQ10 is such an albatross. It is very hard to absorb in the body. Just look at the darn thing. It's like an albatross,
huge.
you know. So and then when you go into the blood, that's only in the blood. This guy is supposed to be in the cell. So the best way to make CoQ10 is actually let the body make CoQ10. Probably evolutionary bend. Our body don't depend on external CoQ10 because it's very difficult for this very good molecule to be gotten from the outside. So I know time won't permit this time. We also make this compound. It's called GG, and GG is required for the synthesis of CoQ10. And GG, however, much 3 times smaller. This will absorb in the body well, and then let the body do the job to make the others. So anyway, we'll go back to vitamin E.
Yeah,
So
no,
excited.
I love it. I have a couple of questions. So,
Okay.
astaxanthin, you're saying that supplementation of astaxanthin is useless because of the shape, the chemical structure doesn't even make sense for it to even work. Is that what you're saying?
Yeah, for protecting the cell membrane. Astaxanthin
Got
may
it.
have other function in elsewhere. Just protecting the cell membrane, it doesn't work. Now, and maybe if I say like this, the audience will appreciate it better. If I know you're from Florida, many of your listeners may be there. If you ever come to visit New England in the fall, for 2 brilliant weeks in October, you will see the leaf turn color into beautiful orange and yellow color like that. Before that, it was all green color like that. And then after 2 weeks after, all the color disappeared, turn brown and die. Let me give you the simplistic understanding of that. The leaf have to photosynthesize. It needs the opposite of what human beings need. It needs carbon dioxide, and then it releases oxygen. That's how you remove carbon from the atmosphere, by the way. So if you don't do this, then all the carbon we produce, they're just circulating around, but they take the carbon, CO2, you see, take carbon, and then they release the O2, you got the carbon in the plant. Very simple like that. Yeah. And then they make all kinds of chemical for you. That's a carbon sink. It's a beautiful carbon sink. Now, why in the fall it turned yellow and orange? It turning down its hormone. It's going to sleep now because it's going to go to hibernation. So then you see the beautiful yellow orangey color. What are they? They are keratin.
Yeah.
They are keratin like astaxanthin, like lycopene, like zeaxanthin, like that. Why are they there? They are there because the UV is radiating on the leaf. If we were to have our body like that, we would have tumor all over our body, on the skin like that, but the leaf didn't. So the keratin is there to capture this oxygen-free radical, so the leaf does not get destroyed. Now, that is where keratin works the best to protect oxidative damage. Notice that though. Let me finish that one. The leaf is not oily. So vitamin E in the leaf is no good. So if you want to protect the cytoplasm, vitamin E should not be there. It should be keratin. But if it is oil and fat, it should be vitamin E and not carotene. You got it? So
Yeah.
it depends on what kind of oxidation. But I think that for human being, when did you last see a human being that only have about 15% fat? It is rare. You will see a human being, we have the other end. We have 35, 40, 45%. We have that kind of a problem. If we have a 15% fat person, okay, they need other kind of antioxidant. Vitamin C, other things that we can talk about more. But for most of us are not like that. I hope I communicate enough to know why you need vitamin E type protection when we carry the amount of fat that we do. Very unlike that from a plant, especially plant from a leaf. Next time, you just tell me, when do you last have eaten leaves or vegetable that is full of fat? I cannot think of one.
No, not unless you add the fat. Yeah.
Yeah, and that's where the keratin's supposed to be to protect Now, polyphenols also come in. Polyphenol are in between. Some polyphenol are water soluble. Some polyphenol are lipid soluble. So they could be in between. They can be found in fruit. They can be found in the skin of the grape. They can be found in the root, the stem, and everything else. But uniquely, in the fat and the oil of a plant, you'll find vitamin E. You seldom find a lot of polyphenolics in the vegetable oil. Also, you seldom find other carotenoid. Not never, seldom find carotenoid. When did you last see vegetable oil or fat that is orange color? It's just not common. Little bit yellow, yes. By the way, the little yellowish thing you see in corn oil, that's lutein, small amount, because you can see from the corn like that. So there is some telltale sign, but not. I know time doesn't permit. Another time you ask me, right? During the ovulation cycle of women, there is a part called corpus luteum. You and I are men. We don't know this. You can Google the corpus luteum, like during that cycle. During the corpus luteum time, the word corpus luteum is probably where the word lutein from. Most people don't know this. And the highest concentration of lutein and zeaxanthin is in the corpus luteum. So this lutein and zeaxanthin is actually creation of life, like that. Most people don't know. We only know lutein and zeaxanthin to protect us from macular degeneration, filter out the blue light. Correct. But when it is inside the placenta growing, that's big time oxidation. And so the mother needs to be protected while she's feeding the baby. So I know we are talking about tocotrienol and told you. So carotenoids are important, but they do different things to protect oxidation. But if it comes to fat, then it is vitamin E. But other antioxidants have protective capability for other things in the body, but not necessarily the cell wall.
Okay, got it. And I love it. Super fascinating. And we could talk for hours, but I know we only have about 12 minutes left.
Oh my goodness.
Let me ask you this. One small little question on the astaxanthin piece, and then I want to transition into the different types of vitamin E and the role of vitamin E in oxidized cholesterol. So what about, you're mentioning the cell wall, the cell membrane. What's the difference between the cell membrane in terms of the chemical structure versus the mitochondrial membrane? Would astaxanthin make more sense with the mitochondrial membrane, or even with that, would it not fit in that piece right there?
As far as membranes are concerned, whether it's on the cell wall or in the organelles of the cell, they are the same. I have heard that astaxanthin works really well to promote mitochondrial respiration, like that. But the studies that I've seen in it, they seem to be in vitro study. In other words, they extracted the mitochondria and then they study it like that. So cellularly, I don't know how that works. And then they have done, however, study with astaxanthin with athlete and able to improve their performance. I did read a little bit like that. So I just have trouble thinking chemically how the astaxanthin reside in the cell wall. It's just
Yeah.
that easy. But other than that, I don't know. Next time, if you look at the structure of astaxanthin, you look at the structure of the cell membrane, you know exactly what I mean. Nobody addresses it, but when you do, people will just draw blank. They don't know how to deal with that. So,
Yeah.
yeah, it's supposed to follow some very simple chemistry and biochemistry, but it's not following, But I want you to ask me about the antioxidant and the lipoprotein. That's a very important one.
Yeah, and that makes sense. It just if you just look, you showed it for those who are listening on the podcast. Watch the YouTube video, and you can see what he showed when it came to the astaxanthin, how it doesn't fit. What are the different types of vitamin E? Because somebody's going to hear this episode and they're not going to understand. There's a specific type you mentioned from the Annatto plant that you want to maybe get in supplement form. So, what are the pitfalls of vitamin E? Some of the red flags when somebody's buying a supplement. What are the different forms of vitamin E?
Okay. The two major forms of vitamin E are tocopherols and tocotrienols. The tocopherols, you can read them in your cereal box. And then the tocotrienol, you just about not find them. If you go to a store to look for vitamin E, 95% of them will be tocopherol. Very few, about 5% tocotrienol. And in the tocotrienol, you're going to find three. The less common one is rice tocotrienol from rice bran. And the second more common one is from palm oil, like that. And then this almost very little found is called annatto from this plant that I show you. Annatto plant like that.
It's a beautiful plant.
We use the annatto for coloring cheeses. Next time you see Dorito chips, cheese, and then you can see this kind of a color. We remove the color, and then the vitamin E is in there. The vitamin E I discovered was about 25 years ago. I actually went to South America. This is a chance finding, and it's kind of spiritual to me. I went to South America after the discovery of lutein and zeaxanthin on the back of the retina like that. Now everybody knows that it's for macular degeneration. Then people didn't know. I knew that if I look for a large a marigold plant, you can see a younger me in this book that under me, you can see that I'm looking for a marigold, but I did find the marigold plant. But about 30 feet away from me, I saw this annatto plant, and the color is again a carotene. Notice this. This is a very unusual fruit. It doesn't have a flesh. All fruit that we have a flesh, and then the color, that's a carotene. And carotene are super unstable. It's supposed to be bind to the cytoplasm or bound to protein, but this one stay in your hand. The British call this the lipstick plant, like that. So intuitively, I thought that there must be a powerful, notice how I asked the question, there must be a powerful antioxidant that protects it from degradation. I was expecting it to be a polyphenol. So surprisingly, not a polyphenol. More surprisingly, it's not a tocopherol, and most surprisingly, it only contained tocotrienol. I was already an expert in tocotrienol this stage, so when I found this out, then I have already found this from rice, which have 50% tocopherol and 50% tocotrienol. And then I also found this from palm, which have 25% tocopherol and 75% tocotrienol. In early days, when I did clinical studies on this, we found that the tocopherol interferes with the function of tocotrienol. This is a different kind of concept. It is antagonistic to the function of tocotrienol. So I kind of like leave the tocotrienol research for a while. And then I found this from Annatto. The Annatto is completely free of tocopherol. So now I got a chance to go back to doing clinical study because I don't find it contained tocopherol that put brakes on the function of tocotrienol. So the last 25 years, I've committed to do research on them after I found them. So now tocopherol, tocotrienol. And of the tocotrienol, the most active one is delta tocotrienol, like Delta Airline, and gamma tocotrienol, like that. And this annatto, you wouldn't believe it. It literally contains 90% delta tocotrienol and 10% gamma. So in other words, it is almost as good as a drug itself, except it is not a drug and I did not manipulate it. The lovely plant make it itself. By the way, I bring this back up again. This is carotene. You know why the plant make tocotrienol? It make tocotrienol to protect the color from degradation. That's it.
That's what I was going to ask you. Like, why do you think the plant makes this the only
That's it.
plant that makes this
That
unique?
otherwise the color would just disappear. No time, Otherwise the color would disappear like the foliage color. 2 weeks,
Yeah.
gonzo. But this thing here, once it's on there, it stay there for months and months. And you know why the plant does it that way? It does it that way to conserve in making the fruit, to deceive the birds of the air and the Amazonian tree frog so they can swallow the seed and poop the seed and hence procreate the life cycle. That's it, So I always respect that. The plant never make the tocotrienol for you and I. We're just lucky that we have this. So because of that, I know our time is limited now. I have committed the last 20-something years of my life to do chronic condition. So the chronic conditions we have studied, Ben, are dyslipidemia, cholesterol and triglyceride, metabolic syndrome, prediabetes, including insulin resistant, diabetic, and more recently, we finished studies on fatty liver disease. And the last of these chronic conditions, my colleague in Texas are doing, and on men and women with obesity. So these are clearly chronic conditions. So there you have it. This is a shorthand of all the things of my last 25 years put in a capsule.
It's amazing. Yeah. And we're going to bring you back for a round 2, especially because you have some studies coming out. But last question will be this. And if you can answer in 2 minutes, if you can, because I know we're running out of time. What's the role of taking vitamin E for oxidized cholesterol? Let's say somebody does like a lipid panel, LDL. They have a lot of these small sticky particles. Can vitamin E potentially help with that?
Amen to that. If you think of a particle, they are lipoprotein. And the lipoprotein don't exactly follow everything like the cell membrane, but close enough. They got more other stuff in it. Inside the core will be triglyceride. Now, they have tested ex vivo outside the body as well as in the person. They consistently find that the LDL particle and the HDL particle, the bad and the good cholesterol respectively, they are protected from oxidation. Oxidized LDL particle is considered atherogenic. That means that they become very sticky, they cling onto your artery, and then they make a plaque. But if they are not oxidized, they're potentially bad, but they are not bad in itself. And tocotrienol is known among all the vitamin E to protect the LDL particle from oxidation. I'm saying it in the simplest way I could possibly to you. And how much to take? About 100 to 200 milligram per day, 100 for a smaller size person, 200 for larger. And for mild chronic conditions that we did it on people with pre-diabetes, about 300 to 400. And for people who are diabetic, and people with fatty liver in a clinical study, typically 400 to 600 milligrams. Make sure you take it with a meal, not on an empty stomach. If you want to know where to get this, you go to our website. We don't make finished product. We only make them in big, big buckets. And our website, American River Nutrition, or you type my name, Barrie Tan, Barrie Tan. Then you go on. You can download all the papers. If you want a copy of my book, which I did this as a labor of love, you can type this, barrietan.com/book, and then you can download the whole book. You can read, and then I put in all the references. You can find out yourself. I truly do this because I think that this matters to people's health, and I'm great to be blessed that I stumbled across this plant 25 years ago, and I have not strayed away. I consistently do the study. Maybe next time when you do a second interview, I can speak a little bit more about the GG, which I know we don't have time this time.
Oh, I love it. We're going to put all your information down below. And, the last question I always ask everybody is about another supplement called vitamin G, which is gratitude. And I was going to ask you what you're grateful for, but you just said it. You're grateful for last 25 years of this research, putting it out there. We are grateful too, Dr. Barrie Tan. So thank you so much. I look forward to bringing you back. And I really had a great conversation, a great time with you today. Thank you so much.
Thank you, Ben.